But what we started thinking about was at Site 2, which is the one that had both high phosphorus and high biomass, you have this real dense canopy of Chara there. And what Chara does is as it's growing, it is covering up Chara below, which gradually kind of dies. I think the term for it is senescence. Are you a biologist? Is that the term you know? Did I say it right? Senescence? Sentience? Does you recognize that term?
Sounds familiar.
Okay. Well, it's as the plant grows. I'm not a botanist, but as the plant grows, it kind of covers the plant underneath, which causes it to die back. So it happens with perennials. So anyway, you've got this dense canopy, and you've got some organic decay under there. So we thought initially, well, maybe it's just that there's more organic decay because there's more being covered up because there's just so much growing. And then we started sort of putting this together that, okay, that could release more phosphorus, but it could also mean lower oxygen conditions, you know, in this real dense area just right below that canopy, right? Which unfortunately we didn't measure, so we need to go back and like stick the probe right through the dense canopy there to test this idea. And then again, we've got that low oxygen there, so that means that we're inviting those conditions that are crying for phosphorus to be released from sediments. And then looking in the literature, we found several other studies that had seen a similar, or sort of bringing up a similar, has similar observations, and we're thinking along the same lines. We can also bring calcium carbonate into this as well, because if we've got low O2, we've probably got higher CO2, and so down here, you know, below the Chara, even though we may be forming it above it, we may not be preserving it, so whatever phosphorus was co-precipitating may not have actually co-precipitated, but ended up being released back to the water column. So that was our explanation for that, which was pretty neat to sort of put that together. So this is still back to Darren's data, and just looking at that, I talked about how he measured the inlet and the outlet, because we wanted to see where the source is. So was it coming in from the inlet, which initially we thought it might be? You guys remember this last fall was actually drier than average if you look at the data. So we really weren't getting hardly any phosphorus, low values of phosphorus coming from the inlet. So here's phosphorus. This is the mass flow. So when we look at the discharge, the inlet, we just have, it really doesn't change through the fall. Even as we started to get more rain, the ground was dry enough that there was, I think, a lot of recharge going on in the aquifers above, or in the watershed, and we just really weren't seeing much of a signal. Little bit of a signal with in the outlet, a little decline in October, but the key thing here is that this is micrograms per second, is that we see that the outlet has higher amount of phosphorus than's coming in, right? So, and we took out the flow point here, so we're just looking at the mass. And what this tells us is that the lake actually, one of the questions was, is the lake acting as a sink or source of phosphorus? Because we know there's all these things going on in the lake that can produce phosphorus, but also there's a lot of sedimentation in lakes, and that takes out phosphorus. So lakes can be both, and so we wanted to see what was happening, and we found that during this dry fall, that there is actually more, if we're looking at the inlet and the outlet, there's actually more leaving the lake than there is coming into the lake. So it's a net source, right? And this was, the other thing that happens is that when at the sediment water interface where that phosphorus is being released from the sediment, if you have lower amounts of phosphorus coming in, that actually, through the osmosis, the balance of concentration of phosphorus allows more phosphorus to be released from the sediments. So that's another thing, that it's not just that there's less coming in from the inlet, but it actually encourages more to be released from the sediment. So that's another kind of interesting thing that I want to learn more about. Okay, so some conclusions here. Submerged macrophytes like Chara, we have some evidence that they actually do regulate phosphorus through both top-down mechanisms, and that low oxygen conditions produced by stratification can cause the release of phosphorus from sediments through bottom-up regulation. So we see Kara working top down, and sediment release and stratification from bottom up. This also made us start thinking, and I know a lot of people who work for the state are thinking about this now in terms of monitoring these lakes. But if we increase the length of stratification, then that means there's more time for phosphorus to accumulate in the water columns, right? Because there's going to be more release from those sediments. So these are one of these implications that we look at: mesotrophic lakes turning eutrophic lakes, oligotrophic lakes turning mesotrophic lakes. That's the sort of thing that we start to think about when we look at these interactions. So also we know that the sedimentation of calcium carbonate is influenced by productivity, by water depth, and by temperature. And that when we looked at the dry conditions that were there this fall, this resulted in internal release of phosphorus from the sediment, and it resulted in a net source of phosphorus from the lake to downstream tributaries. So this is Darren, and this is us and the person who owns Twin Ponds is a Norwich alum, and he loves to have us come. He lets us use his paddle boat, and so I always call it resort science, because we go out in the paddle boat and take measurements, and so it's a lot of fun. So I think you guys, is that pretty good? Are you talked out? Yeah? I think I just had one other sort of thing I wanted to get to that, but in terms of looking at the sediment, just because that's the other big thing I do here, is take these sediment cores. And just this is what the marl looks like, that calcium carbonate mud. And so we're finding these in the cores and saying, man, what's that doing there? And so we take these cores and looking at them through time. I actually worked with a colleague in the University of Wyoming on this paleo work. And this is from a shallow water core from the present to about 14,000 years ago, which is about the age of the lake when it was decomposed. And this is looking at just the composition of the sediment, percent carbonate, percent inorganics, and percent organics, and looking at those changes through time. And we look at some of these big transitions stratigraphically. We've got clay dominant here, this gray stuff, and calcium carbonate dominant. A couple other transitions here. So this is the last slide, I promise. So we spent a lot of time looking at this sediment and getting all kinds of other information as much as we can. We look at pollen preserved in the sediment. We get isotopes from the bulk carbonate that is precipitated out, oxygen isotopes. We've got our sediment compositions. And we also look at these little things called ostracods. Little shells look like lima beans. You have some pictures here. And we can, from this, sort of figure out environmentally what's going on. That's a big spruce pollen grain. That's some of the carbonate incrustations that we find around the Kara that we can use to get Delta O18 records. And then, let's see. Here's the ostracods. So this is what they look like in the core, these little lima bean shapes. And each one you can start to relate to different aquatic conditions. So we can both figure out what's happening on the terrestrial and then what's happening in the lake, and kind of try to put it together to reconstruct past changes in climate and environment. There's a little ostracod. And I think that is probably the cutest thing I've seen in a shell before. All right, that's it.
Any questions?
Blown away, huh?
So, I have a question.
Yeah.
Like that. So when we look at the phosphorus levels rising in a body of water,
Yeah.
so you're saying less is coming in, so more can be released.
Yep.
So what does that spell out for water bodies on the lower end? So we're always concerned about all these phosphorus levels from farms. And
Right.
lo and behold, these bodies of water have been storing them for us.
Well, okay, yeah, that's a great question. And have you guys heard of legacy phosphorus, that term before? So phosphorus that comes in, our next question is, we still really need to go back and figure out where the initial phosphorus is coming from, and I've got different ideas on that. But originally, you have, external input of phosphorus through excess runoff, stormwater, agriculture, that kind of thing. even if you like looking at Lake Champlain, if we say, all right, let's turn off the phosphorus faucet, right? We're gonna cut, stop agriculture, put filters up everywhere, and really bring down that input way, way down. Well, there are places like Missisquoi Bay where we would still have a phosphorus problem for the next 2 or 3 decades. And that's because of this legacy phosphorus. So phosphorus is very mobile. It moves through the lake system very efficiently. It comes in, it pretty quickly gets taken out, but then it pretty quickly comes back in. So it just goes round and around pretty efficiently until finally it actually gets removed permanently into the sediment below. But they found that phosphorus is actually so mobile that they found phosphorus migrating up from the sediment like 20 to 30 centimeters below the sediment water interface. So for that reason, they'll think about some other treatments to actually help this happen. So places like Missisquoi Bay, they are thinking about doing a alum treatment where they take aluminum hydroxide, sort of just like the iron, and that forms a similar coating that kind of protects the bottom from the release of phosphorus.
What kind of effect would that have on the plant?
That's a good question. Well, they would do it just in areas where, in the deeper areas where you have limited in terms of the submerged vegetation there. So at that, it shouldn't have too much effect on the plant life. But I don't know about fish and other sort of the aquatic ecosystem, but they've done it fairly successfully in lakes, and it's pretty costly, and it lasts 2 or 3 years, and then you have to do it again. But it does, the data shows phosphorus comes way down. And so you in some cases, you have to wait or you have to do both to get immediate results. Yeah. So one of the things, another potential source, thinking about this legacy phosphorus, and I'm not sure how far back to go, but we took a short core this fall, and looked at, just sort of looking at changes, sort of trying to link some historic land use changes to changes in the lake. And one of the things we see is this big increase in sedimentation rate and organic matter that we think is associated with the deforestation that occurred when you're in the early 1800s to the 1800s. So then I think we've got this pile of organic matter down there, that is decomposing and another source of phosphorus. So that's another thing to look into. I think so too. Right. So have you guys done a lot of, what are your majors? What are the majors here?
Sustainability.
Sustainability.
Environmental science.
Environmental science or, yeah,
Science.
science, okay. So there's environmental science, sustainability,
Natural science,
natural science.
which is really general.
Okay, so kind of there's natural science and then a little more on either side.
Yeah.
Cool. But you're all part of the same department or more or less?
Mostly, yep. So was it Twin Pond that
Yeah,
you had a net, it's a source of phosphorus?
Yep.
There's more carbon leaving, or more
at least
phosphorus
it was
leaving.
last fall.
So that's my question.
Yeah,
So do you think that changes in wet years, dry years?
I do. My guess is it does, and I think that, I've done a lot of sampling on the Dog River too, and I can see this last fall when I sampled there, looking back to previous falls with a class of sampling, that it was definitely a difference in terms of sources. So my guess is, that's another thing, we're going to go back through sort of have to fill in the story to say, well, we need to go back a time and not just wait for a wet fall when I
Right.
happen to have a student who wants to do it.
Right.
But we'll go back in the next few weeks to do, Darren's going to go back with me and we'll do the inlet and the outlet and do the
Right.
whole thing again. And just so we can see in terms of that inlet coming in, how
Right.
much is coming in this is the time of year to test for external input for runoff phosphorus, really. That's sort of the standard time.
So I tend to think of ponds as either being phosphorus limited or nitrogen limited or oxygen limited. Does that mean that this might be phosphorus limited some years but not other years? Do you think that?
I don't think this pond in particular is ever I think, well, in general, ponds are more phosphorus limited than nitrogen limited, and lakes are too. So that's sort of a general thing. But that's a good question. I think that phosphorus, there's probably always plenty of phosphorus in this pond. I think that in terms of supporting the Kara, there seems to be plenty to support that ecosystem. And it's a pretty rich ecosystem there. I'm working with one of the biology professors, and I bring him back samples, and he's trying to grow Kara in his lab. So I was looking over at your thing.
Oh.
And he finds all these planera, like all these really cool little things he's been finding in there that indicate that it's a really pretty healthy ecosystem.
Right.
And so I'm kind of looking at it like, I feel like what we're seeing here is that this Kara ends up being a regulator that's sort of, even though we've got this source of phosphorus either from the river that's come down and is now being released from the sediment, but it's helping maintain the lake in this mesotrophic state, which is relatively clear in terms of water quality and a healthy aquatic ecosystem. So
Yeah.
I actually see, and so that despite the fact that we have high amounts, that this has a regulating factor, and that's there's also a thing between ponds, small ponds, or small lakes and ponds, where it's either phytoplankton dominated or macrophyte dominated, and it's they see this sort of threshold between the two, where you have this switch of states, ecological states, and that has to do with the limitation of, and you see it. I mean, it's really clear. There's the macrophytes in one area, phytoplankton in one area, and they don't cross for many reasons. But one is the partitioning of nutrients.
Does that
right?
come back to the PN ratio? I think I saw a talk about that years ago.
Yeah, most of that, it does come back to phosphorus, and it also comes back to the turbidity in the lake. So the more turbidity you have, then the Kara is not going to do very well, and then that's going to encourage the algae, the phytoplankton doing better, and then that kind of goes this way, right? So fish have a role in that too,
Yeah.
but then other studies show that it's all phosphorus driven. That you can input phosphorus and it'll cause the lake to flip
Right.
from one to the other.
Any other questions?
Right? Well, thank you. Thanks
Thank
for
you for
listening.
coming.